After we have the concrete mix proportion as shown in the table, it is noted that both coarse and fine aggregates are in SSD condition. Actually, coarse and fine aggregates used in construction site are not SSD condition, may be dry or wet, depending on the weather of the mixing day. We cannot control the slump or quality of the concrete. Thus, we have to adjust the water in concrete mix proportion due to the moisture content in aggregates. For example, if it's raining today, coarse and fine aggregates are wet. The water content in the mix proportion must be reduced because excess water will be obtained from aggregates. Conversely, if the fine or coarse aggregate is in dry condition and the moisture content is lower than the water absorption at SSD, we have to add more water content into the mix proportion in order to compensate the water that absorbed by aggregate. In this problem, the coarse aggregate has water content 2% and water absorption 1%. Sand or fine aggregate has water content 6% and water absorption 0.7%. It is noted that both coarse and fine aggregates have water content more than water absorption. This means that coarse and fine aggregates are in wet condition, and we have to reduce the water content in concrete mix proportion. From this diagram, SSD at this point and aggregate given by the problem are at this point. So the difference between 2 points is the excess water or free moisture content. And the knowledge from the test of the specific gravity and water absorption of aggregates, we calculate and find the water absorption and water content by comparing with dry weight. Thus, dry weight of aggregates are used in the calculation in order to find the free moisture content. In this problem, the dry weight of the coarse aggregate is 1008 kilograms, and the dry weight of sand is 758 kilograms. 2% of the water content and 1% of the water absorption for coarse aggregate, and 6% of water content in sand and water absorption 0.7%. So from this step, the excess water or the free moisture content is 50.25 kilograms. Thus, the water content used in this mix proportion is 185 minus 50.25 kilograms, and the missing water of this concrete is 135 kilograms. After we know the water content in the mix proportion, we must to find the amount of coarse aggregate in wet condition. For the quantity of coarse aggregate in wet condition, calculate from dry weight of coarse aggregate multiplied by 1.02. 1.02 is 2% of water content. Thus, the quantity of coarse aggregate in wet condition is 1028 kilograms. For the sand, the dry weight of sand is 758 kilograms. The water content of this sand is 6%. So the quantity of fine aggregate or sand in wet condition is 803 kilograms. So the mixed proportion of concrete after adjust the weight of water is shown in this slide. It is not that the weight of the water is not 185 kilograms, but it is 135 kilograms. The weight of coarse and fine aggregates are more than the weight as SSD condition that are 1018 for coarse aggregate and 763 kilograms for sand, because the added water is the weight of the water in aggregates. Next step, use this mix proportion to mix concrete and check the slump of fresh concrete. If the slump of fresh concrete is not in the range 25 to 50 millimeters, add or reduce the water content and recalculate the mix proportion and mix concrete again. When you add or reduce the water, you should add or reduce the cement content to keep the same water cement ratio, that is 0.45 for this problem. If the slump of concrete meets the requirement 25 to 50 millimeters, place the concrete into the standard cylindrical mold having 15 centimeters in diameter and 30 centimeters in height, in order to check the composite strength of concrete at 28 days. If the slump of concrete and the composite strength at 28 days meet two requirements, it is suggested that this mix proportion is ready to use.